Afternoon all. Now in the first part of this video I built this little stack of parts. At the bottom there is a 240 milliamp hour LiPo pack, and that's velcroed to a TP4056 charger board, and then on top of that is the MAX17043 fuel gauge. Now that's connected through to the Arduino Pro Mini 3.3 volt version via power and I2C data cables, and then the Pro Mini is connected through to an OLED, and there on the screen of the OLED we have LiPo, and the state of charge is currently reading 79.9%, and the voltage of the battery of the LiPo is reading 3.93 volts. Now I've set the software running in the Arduino here to update these display items every half a second. Now of course that doesn't mean that there's new data every half a second, but that's the rate at which this information is being written to the OLED. So what code is needed to interrogate the fuel gauge? Well, if you type in Arduino and MAX17043 into Google, the first result is in the Arduino playground, and if I click on that, that takes us through to here, and it says an Arduino library is available. Let's click on that, and where do we go? We go to www.lucadentella.it, and this is a little piece all about Luca's library that he wrote for the MAX17043. And by reading just 3 pages on here, it's in Italian, but it's fairly easy to make sense of it. You probably will get a translate option up there. You can work out what's required to be put into the sketch. So here on page 1 there is a link through to GitHub. If we click on that, it takes you to this page. Now down here there is a download zip file button. So download that, put it on your desktop, and then go to Arduino IDE and install the library. Now I found that I had to slightly rename the zip folder because my version of Arduino IDE didn't like names. This is my version here, Arduino 1.5.6 R2. It didn't like names with hyphens and underscores in it, so I just took those out, and then everything was fine after that. Now once the library is successfully installed, you should find under examples there's a new one right down the bottom, MAX17043 master. As I say, I removed underscores and hyphens and slightly shortened the name, and you should see that there are 3 example files there in the examples list. Now on page 2 of Luca Dentella's website, you'll see that he gives instructions on what includes you need, MAX17043.h and wire.h, which is the hardware I2C library. You need to create an instance which he's called battery monitor, and then in setup we do a wire begin, a battery monitor reset, and a battery monitor quick start. Then I found it necessary in my loop function to create a couple of variables which I called SOC and voltage, and then I run these functions batterymonitor.getSOC, batterymonitor.getVcell, some instructions to position things correctly on the OLED display, and put the data on there, and then finally a delay of half a second. So I've whipped through that fairly quickly, but I will put this file, which I've called wearable, in as a comment in the description of this video, and also this font data, which is just a large array. And so what I've managed to create here is a device that sits there running its own battery down, but in the process telling us how much it has run it down. So currently we have 79.6% battery life left. The battery voltage is 3.92 volts. Now, okay, this doesn't really do anything useful at the moment, but the idea is to introduce one of these little transceiver units. This is the NRF 24L01 Plus, and also there's a little tiny surface mount version of the same thing, which I might possibly use. So when this device has got that wireless receiver, it will be able to receive a whole bunch of data which it can put on the display, and then in addition to data that it's receiving, it will also show battery life, and it's possible that there will be information on signal strength and stuff like that, and I can also put that on the display. So I suppose the next question is, how good is this little Maxim integrated circuit? How well does the trademarked model gauge algorithm work? And how accurate is the information that appears on my OLED display? So yesterday I ran this battery down until the fuel gauge percentage showed 0, and fairly quickly after that the battery protection components kicked in and the unit switched off. So I'm fairly confident that the low end of the fuel gauge is fairly accurate. And then this morning I plugged in the charger into the charger board, and when the display got to 100%, I disconnected the Arduino, because unfortunately the Arduino and the display between them take over 13 milliamps, which is a tenth of the nominal charge current. And very shortly after I disconnected the Arduino, the charger board went from a red LED to a blue LED. It was only about 20 seconds, so the battery was fully charged. Now whether it was moderately overcharged or not, it's hard to say, but certainly it was fully charged. So I suppose it's a matter of personal taste really, whether or not you incorporate a chip such as the MAX17043, or whether you attempt to do your own algorithm to calculate remaining charge, the state of charge of the LiPo, from a measured battery voltage. But anyway, I'm quite satisfied with the result of this particular project, and now this is where my wearable wristwatch device, where it's currently at.